Good afternoon. I'm Stefan Mattei from the team Geosequestration. Since pre-industrial times, atmospheric CO2 concentration has roughly tripled, and we are witnessing currently the effects of runaway climate change as illustrated by the 2019 bushfires and the floods of recent years here in Australia. All this extra carbon in the atmosphere comes from the combustion of fossil fuels, but it doesn't necessarily need to be emitted into the atmosphere. It is our vision that this CO2 is captured at source, compressed and injected into the rock formations in which it was concentrated over hundreds of billions of years in the first place. The solution to do this is called geosequestration. The CO2 gas, which is concentrated in the exhaust fumes from coal-fired power stations, from cement mills and from steel factories, is compressed about 300 times. It becomes a liquid-like fluid, and it is injected into the pore space of the rocks, where it is immobilized by a range of processes. Luckily, more than half of the emissions, more than half of the 40 gigatons of CO2 we emit every year can be captured and readily stored by this process. Is it really that simple? Well, the rocks that we want to inject the CO2 into are hidden in the subsurface, and their properties are highly variable. This makes it hard to predict how difficult it will be to inject the CO2 at a particular site, where the CO2 will spread, and whether it will leak to the surface. Regulators around the world already introduced tough rules for the storage, such that there is currently little pore space that has been approved for CCS. Regulators require computer simulation to demonstrate that injection is safe, but the programs for this purpose were designed for oil and gas purposes. So this is where our solution comes into. We have created a new enabling simulation software that improves the prediction, diminishing risks and surprises, that helps to assess the pore space with CO2 storage potential for approval by the regulator, and it enables optimization of storage design. We have already tested this technology in joint industry academic processes, and we have embedded it into a workflow for carbon capture and storage. So our next steps are that we want to conduct many more interviews to connect with the right companies of the hundreds of operators that are now around the world. And we want to find funding to hire personnel to create a services company with traction and a track record that will allow us to upscale these efforts to a level where it really has an impact on atmospheric CO2 concentrations. So please do get in touch. Thank you very much.